Hello, beautiful people. This is part 2 of your Unit 5 pretest that we'll go over so that way you can get all A pluses on your assessment that's coming up. Again, we are on campus, so if you hear a bell or the intercom go off, I apologize in advance. Also, disclaimer, I am human, so if there is a mistake, that's okay. Just let me know where the mistake is, so that way I can learn from my mistakes and then you can learn from my mistakes as well. All right, let's continue. We are on number 8 on the pretest number 2 for our Unit 5 test. Identify the domain and range of each. So identify the domain and the range, then sketch the graph. Now, all of the directions say identify the domain and range first. I usually wait for that because I am a visual person, so I'd like to see my graph before I state the domain and range. Okay, sketch the graph. This is a square root. So I know my options are going to be one of these. And I like to kind of do that off to the side so that way once I start, I apologize, my light just went off. Let's try this and get it to turn on. There it is. Okay, so where was I? Oh, I like to sketch this out just so I know for me how my graph should look like. For a square root, you should know that there is a restriction on the domain, meaning there are things that x cannot be because it will make this negative, and we can't take a square root of a negative number. Always start out with your HK. H is always opposite, okay, opposite. HK is also your endpoint. And again, H is opposite. So we have 3 and negative 4. So where's 3, negative 4? Here's your HK. That is your endpoint, okay? Now, go up 1 or go down 1. Let's do this. Let's do it a different way. I'm going to take the inside, which is x minus 3, x minus 3, and I'm going to set it equal to two things that I know the square root of. I know the square root of 1, and I know the square root of 4. And I'm going to solve. So I know x is equal to 4, and I know x is equal to 7. This way, I know the square root of 4, and I know the square root of 1. So by doing it this way, I know what x has to be. So that way, underneath my radical, it can be a good, pretty number that I can take the square root of. Okay, let's continue. Let's plug in 4. 4 minus 3 is 1. The square root of 1 is still 1. 1 times 2 is 2. 2 minus 4 is negative 2. Number 7, x equals 7. So 7 minus 3 is 4. Square root of 4 is 2. 2 times 2 is 4. 4 minus 4 is 0. And again, for problems like this or questions like this, you want at least 3 points. 2 is not enough. You want 3 points. All right, so let's do, we already graphed this one. 4 and negative 2, 7 and 0. Again, I'm looking at my little cheat sheet here that I made myself, so I know it's going to be one of these. So it's either going to be, I'm guessing this one, but let's see here. I'm also looking at my A value. My A value is positive, so I know it's going to be an increasing function, so it's going to go up to infinity. So I'm going to curve it just like that. Once you have graphed it, to me, it's easier to identify the domain and range. Domain, what's the smallest x value it can be? The smallest x value is negative 4. What's the largest x value it can be? Well, if it goes off to infinity, the largest value is infinity. Brackets for numerics like this, because it can be negative 4, I can put negative 4 in here and make it work. And then, can I put negative 4 in there? Oh, excuse me, I got it flipped up. All right, let's try again. This right here is for my x values. I'm glad I checked. Double check your answers, everyone. We're learning today. Okay, x values, x-axis. What's the smallest x it can be? 3. There you go, much better. And the reason it's brackets because I can't put 3 in here. 3 minus 3 is 0. Square root of 0 is still 0. We can do that. And then it goes off to infinity. Infinity is a concept, not an actual number we can grab, so we have to put parentheses. Range. Guess what the smallest y value could be? -4. Brackets because it can be -4. And then it goes all the way again up to positive infinity. If, for example, you had negative infinity, you do not, but as an example, then you would have to flip the number. So you have to always label or place your numbers in order of a number line. So more negative numbers are to the left, positive numbers are to the right. All right, write an equation for the given graph. First off, this is a cube root. And then our formula is f of x is equal to a times the cube root of x minus h plus k. Identify your k, identify your h and k. H and k is your turning point. So h and k is -5 and 3. Whenever you're plugging it back in here, remember that your h value is always going to be opposite. So we have f of x is equal to a cube root of x. Opposite of that is going to be +5. K value stays the same, which is +3. Now you have two options of identifying your a value. A value, you are going to go to the right one and go down to a pretty point, if you can do that. Option number 2 is if that doesn't work, then you have to use a point and plug it in. So I'll show you both ways. So again, go over 1 and go up or down to your pretty point. So since I can't go up because there's nothing there, I have to go down until I hit my pretty point. This will be your a value, and since I had to go down, it's going to be negative. And how many jumps did I do? I did 3. So a is -3. So f of x is equal to -3 cube root of x plus 5 plus 3 is your equation. Let's say we didn't know that it was -3. So I had f of x is equal to a cube root x plus 5 plus 3. Find yourself a pretty point. Let's do this one here. Let's do this one. So this point right here is 3 and -3. So this is y. So -3 is equal to a cube root of 3 plus 5 plus 3. So this is cube root of 8. Maybe that's an a in there. Cube root of 8 is 2. So I have 2a plus 3 is equal to -3. I'm going to add 3 to both sides. Oh, I'm sorry, -3. I was wondering why I was getting 0. So this right here is 2a is equal to -6 divided by 2 divided by 2. A is equal to -3. So you can count or you can plug in a point for your x and y value here. This is y. And then solve. Alrighty. Let's continue. We're starting with module 11 now, so we're almost done. Almost. Okay, number 10. For number 10, what I would recommend is rewriting it. I always like to rewrite these because for some reason I like things separate. I'm trying to grab a sheet of paper here so I can get more room and show you a little bit more steps. Okay, 7 root -384 x to the 6th. Okay, I'm going to split this off based off on the product property. So I'm going to say root 7 of -384 and then root 7 of x to the 6th power. Okay. Here's the thing. This right here can be rewritten as a fraction, which is x to the 6/7 power. But because this is less than 1, in order for this to be 1, we'd have to have at least 7/7. Because this is less than 1, we know that this right here cannot be simplified. So this is staying put. This one, however, we're looking for, we're looking for the same number multiplied 7 times to get us that number. So we can do like a factor tree. And then, let's see here. So let's do 3 times 128. And 128 can be divided by 2 and 64. 64 is, I believe, 8 times 8, right? Yeah, 8 times 8. This is 4 times 2, 4 times 2, 2 times 2, and 2 times 2. Whenever you do a prime factor tree like this, because calculators will not be allowed on this exam, I always like to circle them so I know which one's prime. Okay, so we're looking for 7 of the same numbers. I'm guessing it's 2. 1, 2, 3, 4, 5, 6, 7. Okay, so that means that I can pull out a 2 and have 7 root, let's see, 3 left over. And again, since this is negative, I'm assuming all of my 2's are negative. Okay, so remember how this was left over? So we have to bring that in. So now we have 2 times 7 root 3 times 7 root x to the 6. Again, product rule. So we have 2, 7 root 3 x to the 6th power as our simplified answer. So I'm going to just write our answer here. All right, let's move on to number 11. Number 11 here, you can only add these things if our bubbles are the same. So notice how this bubble and this bubble are different. So we're treating them as bubbles. Bubbles are the same, therefore we can add the quantity of bubbles. So -2 bubble plus 2 bubble, those bubbles cancel out. So we're left over with 3 root 12. But since this is a square root, I can factor this as 4 times 2, and the square root of 4 is just 2 times 2. So I can say this is 3 times 2 root 2. So this can be simplified to 6 root 2. Oh, and this should be a 3. Catching all of my mistakes. This is 3. Because 4 times 3 is 12. 4 times 3 is 12. Let me rewrite this. Should be 6 root 3. There you go, much better. Right, number 12. Number 12, we're going to distribute that root 6. Oops, sorry about that. We're going to distribute that root 6. So we have root 6 times root 2 plus root 6 times 2. Oops, sorry about that, keep doing that. So this right here, product rule, we can multiply the insides. So 6 times 2 is 12 plus 2 root 6. And then I'm thinking, can this be simplified? Can this be simplified? The only thing I'm thinking here that can be simplified is my root 12. So just like we did here, 4 times 3. So this can be rewritten as, 2 root 3 plus 2 root 6. These bubbles are different, okay, different bubbles. So we cannot combine them. This would be our simplest form. All right, let's see number 13. Okay, this says right here, let me use a different marker so you guys can see better. 4 times x squared divided by 2 times root 2x to the fourth. Okay. Writing it out this way, you can see that 4 divided by 2 is just 2. This one here we need to rewrite in terms of a fraction. So I have 2x squared all over 2x to the fourth. And all of this, again, this is all in the bubble, to the 1/2 power. This is 2x squared, 2 to the 1/2. And this is x to the 4 over 2. Oh, sorry, you guys didn't see that. And again, there's different ways of doing this. So if you know of a different way, go for it. So this is 2x squared divided by 2 to the 1/2 power. And this simplifies to 4 divided by 2 is just 2. So again, since this is multiplication, this is division, this is basically saying that we're going to subtract our exponents when the bases are the same. So we have two bases that are the same. We have 2, these two are the same, so we're going to subtract the exponents. Then we have another pair of bases that are the same. We're going to subtract the exponents. So 2, 1 minus 1/2 is just 1/2. 2 minus 2 is 0. Anything raised to the 0 power is 1. So this here is just the square root of 2. Okay. Let's do one more. Write each expression in radical form. So radical form, here's your radical, here's your bubble, right inside. Your exponent is 1 and your index is 4. You don't have to write this 1 here. I'm just saying that this 1 came from here. Your power comes from here, and make sure that anything in parentheses remains in parentheses. All right, this is the end of part 2. There will be a part 3 to wrap up the pretest number 2 for unit 5. Again, I apologize for any mistakes that occurred. And then if there is a mistake that I did not catch, please let me know. Thank you for watching. Bye.